Hello and welcome to the video. We're looking at a tricky question on internal resistance for A-level physics. We've got a practical circuit in which a variable resistor is used to control the brightness of the lamp. The voltmeter reading is monitored as the variable resistor is adjusted to make the lamp brighter. Part 1, explain why the reading on the voltmeter decreases as the brightness of the lamp increases. Sometimes in the start of a question it will say internal resistance is negligible, and the fact that it's not mentioned there means that our knowledge of internal resistance is likely to be needed here, and it could well be that knowledge that it helps to explain this question. So if we consider that the power source will have an internal resistance due to the internal mechanisms of that power supply, and when a current is flowing through that internal resistance through the power supply, there will be a voltage drop across that power supply and across the internal resistance of the power supply, and that is known as lost volts. And we can see that the lost volts there is going to depend on the current that's flowing and on the internal resistance of the power source. If we assume that internal resistance is a constant, then as the current increases, the lost volts will increase as well. So let's have a look at what the question is actually asking us to explain. So explain why the reading on the voltmeter decreases as the brightness of the lamp increases. So as the brightness of the lamp increases, it means the current in the circuit must be increasing. So that in turn means that the current through the power source is increasing, which would then increase the lost volts. And we know from the relationship terminal PD is equal to EMF minus I little r. This part of this equation is the lost volts, and this E is the EMF of the cell, which is the maximum energy per unit charge supplied, and some of that is going to be lost. So we can see that as the lost volts increases here, the EMF is a fixed value, then the terminal PD, which is the reading on the voltmeter, will decrease. So what would we write down? The current through circuit has to increase if the brightness of the lamp is increasing. This increases the lost volts. You could say increases the potential difference dropped across the internal resistance, but lost volts is commonly used phrase there. Part 2 of this question. Let's have a look. So the variable resistor is adjusted so that the lamp is at its brightest. The reading V1 on the voltmeter is noted. The second identical cell is then connected in parallel with the cell in figure 9. The new reading V2 on the voltmeter is noted. Explain why V2 is greater than V1. So a couple of things. If we're adding a cell in parallel, then it's not going to change the EMF. So the EMF will be the same. And so the only way that the V2 could be bigger, if we take this equation, if the EMF is the same, then the only way that V2 could be bigger than V1 is if the lost volts is reduced. And so we need to try and explain why the lost volts is reduced. So adding a second cell is equivalent really in terms of resistance of adding a second resistor in parallel, and we know the effect of that. If you've got two resistors of the same value, then it's going to change, and you connect them in parallel, then that's going to change the effective resistance. It's going to halve it. So internal resistance halves, it goes to R over 2. So what do we need to write down to get the marks here? We can say that the lost volts reduces, and we can say that the EMF stays the same, and we can say that the internal resistance reduces. In fact, the internal resistance halves. So that would be sufficient to get us the marks, the 2 marks on this question.